Hi. So I was looking at the problems that I'm assigning for finding the area between two curves when they are left and right or right and left instead of up and down. And I was thinking you're probably, because you need to see them, how they're situated, these are not things we normally graph. So I need to talk about this. Now there's an element of this like this is something you'd ideally want to do in your head, but this is much easier if we're in the classroom and we can interact and you can ask questions if it's not clear. Um, what we're seeing here is their inverse of functions. So you know how if I have f of x equals x squared, that's like y equals x squared. Well, look at this structure. See, everything's reversed. So if f of x is like y, then f of y is like x. So see, this is x equals y squared, and this is x equals y plus 2. We use function notation just, to distinguish one curve from the other curve, but this is what we're seeing. And these are inverses. This is the inverse of y equals x squared. And this is the inverse of y equals x plus 2, because that's how you do inverses. You switch the y and the x. Well, I know that this graph is the standard, hard to do from the side here, excuse me, is the standard parent function parabola. And this one would be the line with a slope of 1 through 2 on the y-axis. And what we're looking at, that's these. Those weren't the given equations. These were the given equations. And these are the inverses of these more comfortable functions. Now, one thing that's true is the graph of an inverse is the reflection about the line y equals x. Now, if you're comfortable with this, it enables you to do it in your head, kind of. So, if I were to reflect this about this line, it turns out when things open upward, like towards the positives, when they're reflected in the inverse, they open to the right, towards the positives. So this is going to turn that on its side. This right here is that sideways parabola. And this is this is the line y equals x. This has the same slope, it's parallel, but it will be reflected beneath it. So this is what that graph will look like. Now I understand, that's very intuitive, like this helps if we're in class and I can do example after example after example so you can get used to it, right? Show you like several parabolas. What does it look like when you do the inverse? Because, this is a little more awkward in this format. Instead, what I'm going to do is I'm going to show you how to put this on your calculator, because you really do need to look at the picture. So if everything I just said didn't make a whole lot of sense, that's okay. We're going to use our calculators here. So the problem is, when we press y equals because we want a graph, it's y1 equals, y2 equals, and these don't say y equals. So we have to fix that. So I'm going to solve this one for y. In order to do that, I would take the square root of both sides. But this is definitely a case where you have to put plus or minus. Now what this means is y can equal positive the square root of x, or y could be negative the square root of x. And if you look at those on a graph, this right here is the top half of that sideways parabola, and this right here is the bottom half of that sideways parabola. That's why you need the plus or minus. If you don't do that, you're just going to get the square root function, half of the parabola. So in my calculator, I would plug this in for y1 and this in for y2, and then press graph, and I would get the whole parabola. See? So now I have something I couldn't graph, and I turned it into what the graph looks like. Now this one, I'm just going to flat out, just move that 2 over. This is pretty easy. So I get y equals x minus 2, and now I'll just graph that. So here's minus 2, so it'll look something like this. And on my calculator, I could put that in as y3, and I would get that picture. And now I can see, and when I see it, I can start to think about what's on the right, what's on the left, what are my limits of integration. Okay, so if you're okay with that, now I'm going to start actually setting up my integral here. So to find the area between two curves when they're sideways like this, you know, left and right, I couldn't go up and down because see right here, I'd get parabola over parabola and that would zero out. I cannot use the normal f of x top and bottom thing. I have to use dy's. I have to go left to right. So I'm going to do dy. Actually, I'm going to write that last because I don't know how much room I'll have. Notice on the right is the line. So I'm going to write the equation of the line first because it's the rightmost thing minus the leftmost thing. Now on the left is the parabola, which would be this. So I'm going to take away the right minus the left. This is a dy integral because I'm going left and right, not top and bottom. And now what I need is I need these two limits of integration. So, since these are in my calculator, I'm going to find them, and, well, I'm going to try to, I'm going to punch this in here. Negative root x, positive root x, and we had x minus 2. Now when I find the points of intersection, I have to be careful which ones I'm picking because I've got all three on my screen. I don't know, can you see that? I've got all three on my screen. So I'm going to press second trace, and I'm going to find intersect. And now when it says first curve, so I'm going to find the bottom one first. I'm on this part right here. I pressed enter. Now it says second curve. I want to make sure I'm on the line, and the cursor is blinking on the line. And now it wants a guess, and I'm getting x equals 1 on my screen, y equals negative 1. Well, this is a dy integral. This is my lower y. This is the value that goes right there. From that, this is my point of intersection. I want the y value, and that's the low one. This is going to be the high y value. So I have to go through the process again. Second trace. I want to intersect. And now I want to make sure I'm on this curve for curve 1. Press enter. And now I want to make sure I'm on the line for curve 2. It'll say it right on the top of the screen right here. And then I'll go somewhere near it for the guess. And now it's saying x equals 4, y equals 2. And this is a dy integral, so I want the y value. See, that's too high. This is minus 1 down. So these are my limits of integration. And now the last step is I'm going to find this integral. So let's get to the main screen. What is going on? See, if I'm in the classroom, I don't have these problems. Okay, so we got minus 1 to 2 of x plus 2 minus x squared dx, and I'm getting an answer of 4.5 units squared. Alright, so the other problem is 27. It's very much like it. I will show you what the picture looks like for 27. Let me erase here. I won't go through the whole problem, but I'll do enough to get you set up. F of y is y squared plus 1. G of y is 0. Y equals minus 1. Y equals 2. Alright, so I have to understand that these are x's. So this is really x equals, and this is x equals, right? That's a mess, so I'm going to clean that up. So that's a vertical line. That is the y-axis. So here is that curve. Y equals -1 is a horizontal line right here. That's a boundary. Y equals 2 is right here. That's a boundary. So these are my three boundaries right now. And this is my last one. What does that look like? Well, it sure looks parabolic. It's x equals y stuff, so it's going to be opening sideways instead of up or down. So I can do this on my calculator by solving for y. So y squared is x minus 1. So y equals plus or minus the square root of x minus 1. So for y1, I put in root x minus 1. And for y2, I put in negative root x minus 1. And that's going to give me the top half of a parabola and the bottom half of a parabola. And there is my last boundary. So this must be the region from -1 to 2. Those are my limits of integration. And then it's the rightmost function would be the parabola. The leftmost function is this line, which is at 0. And this is a dy integral. So that's what you got to plug in your calculator, and that'll give you number 27. Well, I know you might have a little trouble with that, but play around with it. Try to do some of these graphs on your calculator. It's something we definitely need to know how to do. If it's x equals y squared or whatever, x equals a function of y, we've got to be able to tackle that. So play around with it. Shoot me questions if you have them, and we'll be in touch.